Alright, for this exercise of the Model 5, we want to solve an equation of the form logarithm b of a equals c. And we are given an exercise here. We want to solve for x. That means we want to know the value of x that makes this equation true. And the equation is as follows. We have a logarithm base of x of 1 over 8 equals 3. In this case, we want to find the value of x that makes this equation true. We don't know what is the base in which this is true. So let us find that out. How are we going to find that out? Well, whenever we're solving a logarithmic equation, we want to try to take it into the exponential form. Remember, we have two ways of writing exponentials. We can either leave it as the exponential form, as I have it here, or we can write it in the logarithmic form. You can go from exponential to logarithmic or from logarithmic to exponential, and it is still the same. It's just another way of writing it. Sometimes it is more handy to have it in the logarithmic form. Others, it's better to have it in the exponential form. It depends on what we are doing. But in this case, notice that I have it in the logarithmic form. But for the sake of this exercise, I don't want it as a logarithmic. I'd rather have it as an exponential, because when I have it as an exponential, I will be able to solve easier. So first thing that I want to do is take it to the exponential form. That is the first thing that I want to do. I'm going to take it to the exponential form. How will I do that? Well, if you remember the definition, you can rewrite that by taking the base, exponent, and the result. Based on that, I'm going to say that the base, which in this case is x raised to the 3, has to be 1 over 8. That is the first thing that I did here. Just take it from the logarithmic to the exponential form. Now, this looks a little bit easier, right? I have it now in a terrain-derived domain. I don't have logarithms anymore. I have got rid of that, but I still have some things that don't let me solve my x. For example, if you pay attention here, there is a number 3 that is not leaving my x alone. I gotta move it from there. How will I move this? Well, you can take the cubic root of this number by raising it to the 1/3. But because this is an equality, anything I do on the left side, I have to do it on the right side too. Like this. Once I have done this, I can simplify. I know that x to the 1/3 is the same as x to the 3/3, which is x to the 1. Okay? So I will do that here and write this x to the 3/3 equals. And there's another property that tells me that when you have a fraction to an exponent, say square, you can divide the square into the numerator and the denominator. And it's the same. And I'm gonna do that on the right side. I'm gonna leave 1 to the 1/3 over 8 to the 1/3. Okay, now I will continue simplifying here below. Here. I will continue here. So here on the left side, that is the same as just having an x, which is what I wanted initially, to leave my x alone. Nothing else is there bothering it. And on the right side, I will just do the operation. 1 to the 1/3 is 1. 8 to the 1/3. We can also write it as the cubic root of 8. So x is 1 over 2. That is the answer to this exercise. X is 1 over 2. Here. 1 over 2. Check. There it is. That's right. Let's try another exercise. In this case, we are given logarithm base 10 of x equals 3. In the previous exercise, the x was in the base. In this exercise, the x is not in the base, but we will go the same way. We want to write this, number 1, rewrite this as the exponential form. If I rewrite this as the exponential form, I'm gonna be left with 10, which is the base, to the 3, equal to x. Yeah, that is just by rewriting it, remember. We can always transition from exponentials to logarithms and logarithms to exponentials, and we won't change the value. It's just rewriting it. And that's what I did here. Now here, is x alone? Yeah, this is actually easier than the last one because here I have x by itself. So I have to do nothing else but solve 10 to the third. What is that? 10 times 10 is 100 times 10 is 1000. The result here is 1000. 1000. Just like that.